We look at a problem from 2017 AMC12B. It is about logarithm with floor function. Here, we try to pick two numbers x and y randomly, independently from the open interval 0, 1. What is the probability that these two numbers x and y have the same value for floor function of log base 2? Of course, it's good to review the floor function. By definition, floor function here is the largest integer less than or equal to x. So when x is an integer, the floor function is itself. When x is non-integer, then we're going to remove the fraction part. Okay, so the value really depends on if the x is positive or negative. For a positive number, we simply truncate the fraction, right? So 7.8, the floor will be 7, 2.1, the floor will be 2. Now for negative number, because we're looking for the largest integer that is smaller or equal to. So in this case, negative 3.2, the floor is not negative 3 because negative 3 is bigger. Negative 4 is the floor. So negative 5.9, the floor will be negative 6. All right. So next, we're going to review what is logarithm. Right. Here, the base 2, when x equal 2, the value is 1. Right. Now, when x is 1, the value is 0. For any base, the value of 1, log 1 is always 0. Okay. So when x is smaller than 0, the value is going to be negative. Okay. Let's look at the curve. So when x equal to 1 is 0, when x equal to 2 is 1, the base 2. This is negative 2 something, right? And if we go up and the y value is getting closer to 0, if we go down left hand side, then the x is getting closer to 0, the value goes close to negative infinity. So when x greater than 1 is positive. Now let's go back to our original problem. Here we need to figure out when this floor function takes value of 0. For example, in this case we know every value here going to lead to a negative value. For example, it's negative 0.6. The floor function will lead to negative 1. So it's impossible for this value to be 0. Then how about negative 1? In order to figure that out, it's good to find the boundary points. The boundary where this log base 2 happens to be a negative integer, right? For example, what is negative 1? And what is negative 2? Or negative n, right? So that's the value here. We're looking for that. And in order for this value to be negative 1, we know that the value is going to be greater than 1/2, right? 1/2 to 1, yeah? And the interval is going to be inclusive here, right? This inclusive on the 1/2 side. This is open interval. Now for negative 2, for this value to be negative 2, we're going to be in this interval here. Like it's half open and this is closed here, right? So on and so forth. Like for negative I, we're going to expect that. Now, what is the probability that the floor function take a particular value, for example, negative 1? Overall, x is going to be random variable from value 0 to 1. And here the interval length would be probability where it fall into that interval, right? So when x fall in this interval, the length of the interval is 1/2. So the probability between 1/2 over 1, that's 1/2. And here the interval getting smaller is actually 1/4, right? So that's probability here, and so on and so forth. Notice that as I getting bigger and bigger, the probability that we're going to have this floor function taking the value of negative I is 1 over 2 to the ith power. Okay. In the original problem, we have two independent random variables. They are both taken from the interval 0, 1. What is the probability that they happens to produce same floor value? That is, what is the probability that they equal negative I, where I is positive integer? Now we know that since they are independent, so the chance is going to be multiplied by itself here, it's going to be 1 over 4 to the s power. As x varies in that interval, actual floor function could be -1, -2, up to -infinity, right? So what we need to do is to sum up this probability over all possible values. So that is a geometric sequence, the summation of the geometric sequence, plug in the formula, 1/4 over 3/4, that's 1/3. Indeed, that's the final answer. So the choice here is D. This is an interesting problem, but as a problem 20, which is toward the more difficult part of AMC12, I think it is approachable if you have a good understanding of the logarithm and also understand the details about the value when x is less than 1. Now, do you know everything about logarithm? If you do, I'm going to pose a more challenging problem from China's math competition. I'm going to post it in a few days. In the meantime, please like, share, and subscribe to the channel.